can contact me or Shoki. She's a co-host here with me. And then you can also take note of our email and reach us later. We'll be glad on assisting you if you have any doubt in the end of the day. So today the idea is just to go through all these icons that we have inside MSO. So when you open the software, you know more or less what can be done with it. MSO is an integral part of Studio UG, but it can also be used inside Studio RM and Studio OP. The MSO sits under the Report tab in this Mineable shape icon, and when we click on the icon, it opens a new MSO tab, a new ribbon inside the software. And then that's how we can interact with it. So MSO is used mainly for defining mineral resources and mineable areas. So the main input that we have is the block model. So from a block model and from a set of parameters, we can define mineral resources, mineable areas. We can create our stope shapes, and then we can even use for open pit mining and use the parameters to represent our mining blocks. And then we can evaluate these mining blocks, cutting with a pit design, and then we can reproduce. You can use the results to categorize material, to analyze dilution, and we also have this approach. And also we can generate different reports from the block model and analyze the resources with MSO. So how it works? Basically, we have as an input our resource model. We have economics parameters, so the cutoff grade, the cutoff values, and so on. And we also have our framework. So the framework is the area we want to generate our shapes. So our stopes, mineable areas, and all these options. And then we have all the settings that will define the method that the shapes will be generated, if we are going to include dilution or not, if you want to include or exclude materials from the analysis, we can run sensitivities. So in these other icons here, we can set up all these parameters. And lastly, we have our output, our results that are in form of strings, so it can be outlines, it can be the stopes itself as wireframes. We can have our mined out block model, and we also have the reports in the end. How the algorithm works in MSO. So the first thing we need to do is to define two, not necessarily fixed, but we need to define 2 dimensions of our shape. So we define our section U and we define our level height. They can be variable across the framework, but we need to define them. And the third dimension of our shape is the one that will be optimized by MSO. So we have this tube concept where with this predefined shape, it goes across the block model, and with this tube, so the tube goes across the block model and try to find the optimal width for that shape. So one of the outputs that we can generate from MSO is the verification wireframes. With the verification wireframes, we can flag all the steps used with the algorithm. So here, the first thing, when that tube that I showed on the previous slide goes through the block model, the first thing that is generated is the slice. So we have these slices that are these bluish things that they basically goes around the block model. So whatever, so here these blocks, they represent our block model, and the blue shape is the area that covers the block model. This blue area here is waste, so that's why the tube didn't define that area for us. So, okay, first step to go through the block model and generate a first shape that involves our ore. And then the next step here is to analyze which of these slices they will be mineable or not. So we define the minimum width on the parameters. So like, for example, this one doesn't respect the minimum width. So the next step will exclude that piece from our shapes. Then the next step is to see if that's seeds that are these red outlines, if these seeds respect all the parameters we put, so minimum deep, minimum strike, and so on. And from these seed shapes, we have the new shapes that are this undiluted stope color that will respect all the parameters we set. And then on this case, when we include dilution in our analysis, the next step is to include them. So we have the diluted far here in yellow and diluted near in green. And if we have parallel lenses in this case, so we have two parallel models here, one here and another one on that side. It also creates for us the pillar color, the pillar shape. That is the pink color that separates the two parallel lenses. And then we have the final verification wireframe in the end with all the steps that the algorithm does. And then another output that we can create. So the tube wireframes, they represent that shape that we defined on the beginning. So these are these defined dimensions here, as I said on that drawing. And then the slices that were in the previous slide, they are taken from each tube. So from each tube, the slices will be generated as the previous one. We can also have the tube strings that are the intersection between the shapes. And here's just the block model displayed as a reference. Another thing that we can do, we can use these custom output fields to set formulas and give new values to our shapes. So for example, here that we are optimizing the gold field, we can use the gold, the tones, and the conversion to generate an ounces column in our reports. For studio users that are used to run the extra command, is basically the same logic here to generate these custom output fields. And then we also, in the end, we will have our stopes. So the shapes, the optimized shapes. We can also have the mined out model, that is the block model only inside these mineable areas. Here it's displayed with the grade legend. And we also have this reports summarizing all the data. So the first, the seed shapes, that red ones, they represent this volume and these tones. After optimization, let me just put the laser point here. So this is the seed volume and tone. So after setting the orange shape to respect the parameters, we have the undiluted total and waste. When we add a dilution, that's how the volume and tones are affected, and so on. We can also have the option to generate the failed wireframes. So when MSO generates a wireframe, but when it adds the dilution, for example, it doesn't respect the cutoff anymore, it generates a fail wireframe because it was trying to generate, but according to the economic parameters, they are not viable anymore. So then we can add this to our output and do the analysis of the failed areas. So today, that's I hope to show you all these scenarios. I hope not to extend too much, but I hope you can have a good idea of what can be done using the software. On these scenarios, I isolated each settings, but of course you can put all of them in the same scenario and see how it goes. So I will open the studio here. And the first thing I will open MSO. So in our MSO menu here, the first thing we do is to set a scenario. So here you can see that we can have a lot of scenarios at the same time. So you can run all of them together, and then in the end you can compare one with the other. Here we insert our block model settings. So this is the block model I use. This is the optimization field. This is the density column, and so on. And here in the top, we just choose which scenario we are going to edit. We can use also a surface or a block model field to control our dip and strike. So in this example, I'll be using this footwall surface to control my dip and strike during the optimization. And in the bottom part of the scenario, we define all the outputs we want to generate. So we can here on the wireframe name to put the name we want, the string outlines. We can put the name we want also, but by default, it just put the scenario name and then the identifier. So here we can define the report where we can insert naming conventions for our stope. We can define the output fields as I showed previously. We can enable to create the verification wireframes or not, that are those ones with the color codes. So the seed colors, lice color, undiluted, and so on. Here we can set the failed wireframes, the tube wireframes. So you don't need to generate all these outputs. You can just generate the stopes, it's fine, but you have all these extra options also. The mine out model and also the stope convention name. So in case you want to generate a stope name as a combination of XYZ coordinate or according to an attribute that is on the block model, we can use them here. The next step is to define the economics. So the main optimization, if we want to go for maximize the stope grade, that is the most common use, or if you want to maximize the metal recovery. So there are these two options there. And then we set the cutoff. That is what is going to include or exclude that material from our shapes. So we have cutoff grade or cutoff value or calculated value that use this expression to generate the cutoff. And here we can set as a fixed value, in our case is 3.5, or a variable value according to stope tonnage, stope thickness, and all these parameters here. The next step then is to define our orientation. The orientation is basically which area we want to analyze. So I'll just load my model here and my extents. And you see that I'm going to analyze all my block model extension. My framework, that is this gray area, covers all my block model. A suggestion that we usually do is when you're starting with MSO, don't use a framework with the full area because usually it can take time depending on the block model size. So when you are learning and when you are trying to see what each parameter do to the shape, we can define just a small area. So for example, here, I just go from my Z 7110 to 730, and then I would just analyze my bottom level. Just a small sample to see how it behaves. And then when you are happy with your shapes, you can extend that to the full block model. Like I did that. So let me go back. I think it was 960. Yeah, so when you're happy with your results, then we can extend our framework to the full model. So here you can use the framework extent, same as the block model, or define manually as I was doing now. The next step is to define our shape. So here is where we define our U and our V. They can be a fixed increment. So in this case, I'm just put the fixed increment of 20 and 20, but you can also set a variable. So like here, you can add the coordinate and your increment and do a variable shape. In case you want to define like pillars between two stopes, you can use this variable option to define them. And it's also possible to use gradient strings in case you need to. So you know that your R drives will have 1% gradient for the water flow. So you can put these strings with 1% gradient and then the stopes will follow it. We will see that in the results later. And then here we set the method we want to use for our optimization. So here we can see that our model strike follows the x-axis, right? So now we want to do the stopes along the x-axis. So here on the method, we are going to select the slice method that's recommended for thin ore bodies, but we can also have the prism method for massive mining and the boundary surfaces to very narrow ore bodies. In our case, we are going to the slice method, and then since our ore body is vertical or subvertical, that is the option we will use. And once the strike follow the X, we are going to choose the orientation stopes along X-axis. That will be that direction. And then this XZ in brackets, they represent our U and V. So when we are editing the U, we are editing the X direction. And when we are editing the V, it's the Z. Then under controls, we can define the minimum stope width and the maximum, and we can also set the minimum pillar between parallel stopes. In this case, we only have one. We don't have any parallel stopes, so we won't worry about the pillar. Then we can set our dilution that can be set according to the foot wall and hanging wall or according to the near far. So this near far, it's regarding that wireframe to control the deep. So where is it? So this one. The near is the nearest to the surface and the far is the opposite side of the surface. So here we can set the dilution with 1 meter, 2 meters, and so on. And we can also use curve tables to, for example, the dilution will increase according to my stope thickness. So it can also be variable. Here we will set our dip and strike control. So what is the maximum and minimum dip and strike that your shape can have, and also the change in the same shape. So in the same shape, I don't want the dip to vary more than 10 and the strike to vary more than 10. We can also do the same thing for the thickness ratio. So from top to bottom, uh, the ratio between your bottom length and your top length cannot be greater than 2. And the same thing from the sides. Then on refinement, we can add extra points to our shape. This we'll see in more detail in the results, but we can add the main shape. If we look in a lateral section, we will see that they have 4 points. On this refinement, we can put up to 6 or 8 points inside to control the shape refinement. And here is how far these points can be. So the 10 meters is a great value. Like, it's not a great value. We usually think something more like 2 meters or things that will be closer to our shape, so we don't have very sharp angles in our refinement. And then in materials, we are able to exclude a certain material inside our model, or include, in case we have gold and silver or copper, you can include a different material in your analysis. If you want to exclude some material, you can set a distance. So if you have a mined out value in your block model, for example, you don't want to include the mined out area because you don't have any resource there anymore. So you can, if you have, for example, a field that is the huge depth representing your depletion, you can exclude that from your analysis, and then you can set a distance. So I don't want anywhere 10 meters close to that, I don't want to include. Then you can set the waste percentage allowed inside the shapes, and also using filters to our results. Then in the options, we have these general options to our report. We have output test stopes that we can use to test how your shape will look like. And then we have the post-processing options that we are going to see also in the results. So basically, the post-processing options, they won't affect the shape of your stope anymore. They can like slightly change the shape, but they won't exclude any stope from your analysis. So for example, here in the stope splitting, it will only divide your stope in a certain direction. The stope smoothing will just crop the corners out and do a more smooth surface, so you don't have sharp angles in between two different stopes. And then we have also the stope merging in case you want to do the analysis with thin slices, but then you want to consider them as a unique stope in the end. So you can merge in different directions also. And then on sensitivities, you can run scenarios to set, they will always set plus 10 and 20%, less 10 and 20% that value. So for example, if I have a cutoff grade of 1 and I activate my sensitivities, it will add more form scenarios. And then we'll have our cutoff as 1, 1.1, 1.2, 0.9, 0.8. And then you can compare the scenarios, the volumes and tones. And then here we can also set the sensitivity for these other parameters. And then lastly, when you set up everything in your scenario, we can run all the cases here that we created. And now let's go to the review part of and see what the results are. So this is my basic scenario, my basic stopes. They are just that square shapes, 20 by 20, the different levels, and so on. I will just color it with the stope number value so you can identify the individual shapes. So when I use the legend, you see each different shape. If each different color is a different stope, is a different shape. Now we are going to compare this basic with the parameters that we can set in MSO. So the first is the dilution. So when we add the dilution, you will see that we lose a few stopes because when we add a diluted material, it does not respect the cutoff anymore. So now we won't have the stopes there. And if we do a vertical section here, we will see that the parameter was set 1 meter near 1 meter far. So we'll see that the stope increases a little bit on this vertical section. Then the other example I want to show is the gradient strings. So I have here my basic scenario, and I add on the settings these gradient strings that represents my levels, right? And now we can see that my stope floor, it's within the gradient string. It follows it perfectly. So we don't need to worry if we are going to go out of our stope because they are exactly where they should be, respecting the gradient. The other scenario is the shape refinement, where we can add that 6 point to our stopes. So if we look closer here, so for example, here we can see that it adds as, so the green one, that is the basic scenario, each stope has 4 points, 1, 2, 3, 4. And then when we add the shape refinement, it can add an extra point here, one here and one here, to fit better our shape. And that's when you need to be careful to not allow to go too far, to not generate sharp angles, and because we need to keep in mind that we want to generate a feasible stope in the end. We want to be able to mine that area. So we need to just to set them parameters very carefully. Next one is the stope merging. So as I mentioned before, the stope merging, it doesn't affect my stope shape. They will be exactly the same. The difference is that we are considering 3 volumes as a unique stope. So if I apply my stope number legend to this field now, we will see that each 3 stopes on the basic scenario is now a unique stope in this one. So we can see the identifiers here. And then the stope splitting is the opposite. Instead of merging different stopes into a same ID, we are going to split them. So in this case, I just split them in half, and we can see how they will look like. So here we have the individual stopes divided by 2. The other scenario is the stope smoothing, that tries to remove the corner between 2 different stopes. So if I use this section here, And we go to that area, for example. So see, the green ones, they are the original ones. They have these corners here, the sharp ends. And the yellow, that is the smoothed. It just goes from here to there, refining that difference between them. Another option that we have is to generate the subshapes. So in case we are able to mine that area, they're a little bit more constrained. So especially when they are body strike extents and they are a little bit irregular. So we allow the shapes to be a little bit smaller than the previous. So here we can see that we have these small shapes. So in this scenario, I allow it to split the original section in 4. So like this and like that. And this will allow the MSO to create the subshape like this. So in the basic scenario, we only have this size. We won't have anything smaller than this. But when the subshapes are defined, we can have extra smaller stopes on these areas. One thing that I forgot to mention about the smoothing is because it's important to use, because when we are going to mine, uh, we can try to create those corners, but we know that in reality we are just going to mine straight. So it's good to include the smoothing in the analysis, because you have a better prediction of the tonnages and volumes that are going to be mined on site. And then the not the last one, almost the last one. So we have this one, the variable z, so we can use that variable coordinates, the v dimension, to set up pillars between stopes. So like in this example, I use 5-meter pillars between panels. So I have a 10-meter stope, 5-meter pillar, 20-meter stope, 5-meter pillar, and then we can already know where they will be inserted. So for example, that output custom fields from the beginning, we can set a formula that if my stope height is 20, it's a stope. If the shape height is 5, it's a pillar. And then they are already identified by the end of your process. For every scenario, we generate 2 different MSO generate 2 different reports, the summary and the complete report, and they are here. So the summary will tell you the volumes and tones and densities, density and grades for the seed, for the dilution parts, and also for the undiluted, so you can compare them. And despite the summary report, we have the full report that tells you all this information for each stope. So for the stope 1, we have these tones, these volumes, and so on. So if we go to the end, we even have the width, the strike, the deep, all the dimensions to that stope. And for your full scenario, these reports, they can also be saved as a CSV, and then you can use Excel to analyze the data better in the end. Here, yes, so in the last scenario that I want to show is the optimum metal instead of optimum grade. So the shapes, they won't change too much when we use the optimized metal, but the reports, they will be completely different. So here we can easily access the summary and detail report for all the scenarios that we created in previously on the settings. So we can go to optimized metal and see the summary report and compare with the basic scenario, how it will increase the volumes, tones, and grades. So we will see that when we try to optimize the metal and the shapes, the grade will be a little bit lower than the basic scenario. That was 14 and now is 13. So that's the overview that I wanted to show you for today. Uh, I'm here available for quick questions if you do have any. We have like few minutes left, so I think that's it. I hope you enjoy it. I hope it clarifies. So I remember like when we are using the Mentimeter to see the expectations for the day, someone answer clarify. So I hope it clarified MSO for you. I hope it can allows you to set up your scenarios. I hope it helps you to implement MSO more in your life so you can enjoy the results and everything that it can generate for you.
Gio, I have a few questions
Yes.
that were asked during the webinar. Then I'd like to read to you that I try to answer, but I think you can elaborate a bit more. The first one is accurate how can we have accurate ore body shape between level intervals?
Accurate ore body shape.
Yeah, between the level intervals. I responded to him that we have the option to use the fixed Z interval.
Yes. So here on shape, we can control the Z interval. So here, if I go to my variable Z scenario, we can see that I have my coordinate and my increment for each section. So I have 20-meter panel and a 5-meter pillar, and 20-meter panel and 5-meter pillar, and so on up to the end of my framework. So I believe that's how we could control with the ore body. I'm not sure if this answered the question. Do you think
I think
so?
so. Yes, I'm not sure. Maybe VJ, if that answers your question, if that's all right. And then the other question, Gio, I had is, can we use both? Oh, sorry. Can we use both footwall and hanging wall control at once, or is there only one option?
There's only one option here. So in the top, we have this control surface. So it uses one surface to control it. We can also set both. If we have a way to set on your block model, you can use a block model field to control it on this. So if you have, in this case, this block model does not have jip and strike control, but if you have a field in your block model that has this value, it can also be used here.
Okay, thank you, Gio. And then there's a question here. Please, where we can find the field where there is XC, YC, ZC. I think he's referring to the
It's so.
centers of the stopes. Yeah.
So on the detail report that is generated for every scenario, we have this X center, Y center, and Z center that represents the center of our stopes. So on this table, we are able to identify that.
And then I have another one here. Is the MSO optimizing per stope, or is it optimizing on a collective scale?
It optimizes per stope. So if we go back to the presentation here, we have these tube shapes, right? So each tube is optimized. So the optimization goes stope by stope, not in an overall. So for each tube, it goes through that area and optimize that slice.
Thank you, Gio. And then I have, can you create variable pillars based on the thickness of the stope shapes?
So variable pillars, so we are here on shapes. Um, we can think and elaborate that. It's
Yeah,
possible to do with this variable. So if you have uh, a way to control that, but I'm maybe this is something that we need to see further and
yeah, I
elaborate
think
a little
so.
bit better. I think this is something that we can take and look into more detail because
Yeah,
these level intervals that are controlled by coordinates and also by string. So for example, if I have my gradient string here, that I use this one, so we have a string to control that. It's possible to use this option, but uh, to vary it according to the thickness, I'm not sure that we have this. But we can like run a first scenario to see how it goes, and then you run a second scenario. So like a preliminary scenario to identify how the thickness will behave. And then from this, you can identify the coordinates for the pillars and include on a secondary analysis.
okay. I'm not sure if we have enough time, Gio, or maybe the rest of the question we can contact the individuals directly.
Yes, I think yeah, I had 45 minutes, so yeah, we are
Yes.
a little bit over time here, but I really want to thank you to everybody who was able to attend.